what exactly lies at the edge of what we can see in the universe? That's been a puzzle for ages, sparking curiosity and theories among scientists and fans alike. But now, the James Webb Space Telescope is on the brink of solving this cosmic riddle with its superpowered lenses peering deeper into space. It recently dropped a bombshell about what lurks at the very edge of what we can observe. When we say edge of the universe, it's crucial to grasp the idea of the observable universe. This is everything we can spot, measure, and investigate from Earth or our space-based gadgets. Right now, it encompasses stars, galaxies, and other cosmic bits within our reach. But what sets apart the universe, with a capital U, from the observable one? Well, simply put, the observable universe is just a tiny slice of the grand cosmic pie that we can make sense of, while the full extent and shape of the whole universe remain a mystery. The observable universe is estimated to have a diameter of around 93 billion light-years. Now, a light-year is the distance light travels in 1 year, about 5.88 trillion miles or 9.46 trillion kilometers. So, picture this. The observable universe spans an incredibly vast area, roughly equivalent to around 546,84568. The Big Bang Theory paints a stunning picture. About 13.8 billion years ago, the universe burst into existence in a colossal explosion. This event set off a rapid expansion, and ever since, the universe has been stretching out at an ever-increasing speed, driven by mysterious forces like dark energy. As it expanded, specks of matter began to clump together due to gravity's pull, giving rise to awe-inspiring formations such as stars, galaxies, and eventually, even planets like our own cherished Earth. Through eons, these cosmic structures grew larger and more complex, leading to the dazzling array of objects and phenomena that we see scattered throughout the universe today. Despite its vastness, much of the universe is actually empty space. To put it in perspective, if we shrunk down our entire solar system to the size of a quarter, the nearest star would still be as far away as 2 soccer fields. And that's just within our own Milky Way galaxy, one among billions in the observable universe. You might wonder, why can't we see the whole universe? Well, there are 2 main reasons. First, light takes time to travel through space. When we gaze at distant objects in the cosmos, we're glimpsing them as they existed in the past. The farther away something is, the longer its light has journeyed to reach us. So, when we study far-off galaxies, we're essentially peering back through time, tracing the story of our universe's history. Second, there's the universe's ongoing expansion. Picture dots on the surface of an inflating balloon. As it swells, the dots drift apart. The same idea applies to the universe. Galaxies are moving away from each other as space itself stretches. This expansion stretches out the light from distant objects, shifting it towards longer wavelengths, which we perceive as a phenomenon called redshift. Eventually, some objects will move beyond our ability to see as they retreat beyond a certain distance. Given these considerations, it's understandable that we haven't yet glimpsed the entirety of the universe. Now, pondering the concept of the universe's edge is a mind-bending pursuit that has captivated scientists, philosophers, and thinkers throughout history. Despite various theories about what lies beyond, the truth remains tantalizingly out of reach. Nevertheless, 3 theories have emerged as notable contenders. The first proposes that the universe stretches on endlessly, with no discernible endpoint. This idea stems from the cosmological principle, suggesting that the universe appears uniform in every direction, implying boundless expansion. The second theory suggests a finite universe without a distinct boundary, akin to a vast sphere. In this model, traversing in any direction would eventually bring one back to the starting point. The third theory, the multiverse theory, proposes a cosmos where our universe is just one among many. Picture a myriad of parallel universes, each with its unique laws and characteristics, possibly independent or interconnected. So, we've explored various concepts surrounding the universe's edge through these diverse theories. Now, let's shift our focus to an extraordinary instrument poised to unravel these enigmas, the James Webb Space Telescope, JWST. This remarkable telescope offers a window into the distant past, unveiling unexpected celestial phenomena from the early epochs of the cosmos. With its cutting-edge technology, the JWST empowers astronomers to peer back into the universe's infancy. And what's more, they've stumbled upon something quite unexpected. In a recent study reported in the journal Nature, the JWST unveiled 6 colossal galaxies dating back to a period between 500 million and 700 million years after the Big Bang. Scientists initially anticipated discovering small, nascent galaxies, but the JWST delivered a shock by revealing these immense structures. These galaxies surpass all prior expectations, reshaping our understanding of the early universe. But the surprises don't end there. Researchers made another astonishing revelation. These galaxies exhibit a level of maturity comparable to our 13 billion-year-old Milky Way galaxy. Each of these cosmic behemoths harbors a stellar mass several billion times greater than our Sun. Remarkably, one of them may boast a mass up to 100 billion times that of our Sun. To put it in perspective, the Milky Way contains a stellar mass roughly equivalent to 60 billion suns. The JWST possesses a unique ability. It can unveil hidden wonders beyond the range of human vision. By detecting infrared light, it captures the faint emanations from ancient stars and galaxies that have endured for eons. Thus, the JWST serves as a time machine, offering a glimpse into the universe's appearance approximately 13.5 billion years ago. Here's where things take a fascinating turn. With the universe estimated to be around 13.7 billion years old, this discovery upends existing narratives, akin to rewriting the annals of cosmic history. Dubbed universe breakers, these colossal galaxies confound 99% of the models previously conceived for early galaxies. Formerly, it was believed that galaxies originated as small clusters of stars and dust, gradually evolving over time. Yet, these universe breakers defy convention. When the JWST's data and high-resolution images became available in July 2022, researchers were left dumbfounded. The appearance of these immense galaxies, resembling prominent points of light, prompted skepticism about their own data interpretation. The sudden emergence of these colossal entities, seemingly beckoning to be discovered, caught everyone off guard. By employing spectroscopic techniques to scrutinize light across various wavelengths, scientists can glean valuable insights into these galaxies, including their makeup, dimensions, and distance from Earth. What's captivating is that this groundbreaking revelation wasn't even at the forefront of scientists' expectations for the James Webb Telescope. It not only surpassed all projections, but also unfolded much more swiftly than anticipated. Moreover, there's a chance that some of the celestial entities detected using Webb data might present something entirely unexpected. While the majority are likely galaxies, there remains a possibility that a few could conceal hidden supermassive black holes. Here's where it gets intriguing. The known stellar mass in the universe is now estimated to be up to 100 times greater than previously presumed. Even considering just half of the sample, this revelation remains staggering. In the meantime, leveraging the formidable James Webb Space Telescope, an international team of astronomers made yet another remarkable discovery. They pinpointed the oldest and most distant galaxies ever confirmed, transporting us back to a time when the universe was merely a fraction of its present age, less than 400 million years post-Big Bang. The light emanating from these galaxies reached us over 13.4 billion years ago, as discerned by the telescope. Similar to the early observations conducted by the Hubble Space Telescope, the initial images captured by the JWST unveiled a plethora of potential galaxies. Now, through meticulous spectroscopic analysis, astronomers have authenticated 4 of these entities, enabling them not only to examine the galaxy's physical attributes, but also to accurately ascertain their distances. To gauge a galaxy's distance, astronomers calculate its redshift. You might wonder, what exactly is redshift? Well, as the universe expands, objects appear to recede from us, causing their light to stretch and shift toward longer, redder wavelengths. The Doppler effect, a phenomenon crucial in estimating redshift, can be observed through various filters in photographs. However, spectroscopy stands out as the preferred method for obtaining precise measurements since it dissects an object's light into its individual wavelengths. The latest discoveries spotlight 4 galaxies exhibiting redshifts exceeding 10, indicating their considerable distance from Earth. Previously, the Hubble Space Telescope had detected 2 of these galaxies, confirming their redshifts to be 10.38 and 11.58. Yet, the JWST's imagery unveiled 2 galaxies even farther away, boasting redshifts of 13.20 and 12.63. A redshift of 13.2 points to a period roughly 13.5 billion years ago, offering a glimpse into ancient cosmic history. Furthermore, the JWST's ambitious Deep Extragalactic Survey, JADES, is an extensive program allocated over a month of telescope time. Its primary goal is to provide an unparalleled insight into the early universe. Conceived in 2015 by a consortium of instrument teams, JADES represents an international collaboration involving over 80 astronomers and scientists from 10 countries. The JADES program commenced with NIRCam, dedicating over 10 days to observing a specific sky region, including the Hubble Ultra Deep Field. Astronomers have been scrutinizing this area for over 2 decades using various large telescopes. By studying the field across 9 distinct infrared wavelength bands, the JADES team made a groundbreaking discovery: nearly 100,000 distant galaxies, each situated billions of light years away. Subsequently, utilizing the NPX spectrograph, scientists collected light from 2150 faint galaxies during a 3-day observation period. This enabled them to unveil the characteristics of the gas and stars within these galaxies, acquiring precise redshift values in the process. With these measurements, astronomers can ascertain the intrinsic brightness of the galaxies and estimate their stellar populations. This comprehensive approach facilitates a detailed examination of galaxy evolution over time. Despite the challenges akin to understanding human development, studying galaxies remains an invaluable pursuit. The early stages of star formation wield a profound influence on the future trajectory of galaxies, much like how our formative experiences shape our lives. It's an extraordinary juncture in history, where the James Webb Telescope's transformative capabilities are unraveling numerous mysteries about galaxies. NASA's Deep Space Observatory Telescope is reshaping our comprehension of the cosmos, unfurling a treasure trove of fresh revelations. The James Webb Space Telescope, JWST, at the forefront of scientific inquiry, is illuminating our understanding of galaxies, planets, stars, and other captivating cosmic phenomena. Launched in December 2021 and slated for a 2-decade mission, Webb is just embarking on its cosmic odyssey. Surpassing the benchmark set by its predecessor, the Hubble Space Telescope, Webb has captured the imagination of both scientists and the public, igniting a surge of scientific fervor. Globally, people are eagerly delving into the telescope's raw data, sharing its awe-inspiring images and gaining newfound insights. Following a flawless deployment, Webb astounded us with its initial snapshots in mid-July, offering an unparalleled glimpse into the multifaceted nature of our universe. Equipped with its advanced infrared telescope, we can scrutinize the most distant galaxies with remarkable precision and peer into the depths of cosmic history. Mere days after coming online in late June 2022, Webb's formidable instruments began unveiling thousands of previously undiscovered galaxies, older and more remote than ever envisaged. Furthermore, The telescope's capabilities enable scientists to capture copious amounts of light from celestial objects like exoplanets and nascent stars, unveiling their compositions and tracing their celestial journeys. This wealth of data is already divulging intricate details about the atmospheric makeup of planets situated hundreds of light years away from Earth, offering tantalizing hints about their potential habitability. But that's not all. By scrutinizing faint traces of light from the universe's infancy, the James Webb Space Telescope has potentially pinpointed the oldest black hole ever observed. This colossal black hole, boasting a mass 9 million times that of the Sun, resides at the heart of a fledgling galaxy that emerged 570 million years after the universe's inception. Thanks to Webb's formidable cameras, capable of peering back in time to the universe's earliest epochs, this monumental find offers a glimpse into the cosmic dawn when numerous black holes underwent significant growth in the billion years following the Big Bang. The origins and proliferation of these enigmatic cosmic entities continue to baffle astronomers. Some of these massive cosmic phenomena emit observable light, produced by the material spiraling into their gravitational abyss. Known as active galactic nuclei, AGN, supermassive black holes or quasars, these objects are billions of times more massive than the Sun, emitting intense bursts of light trillions of times brighter than the most luminous stars. They represent the most extreme manifestation of AGN. As scientists delve deeper into the cosmos, they can capture light from increasingly distant sources, offering glimpses into earlier epochs of the universe. The James Webb Space Telescope, JWST, employs its mid-infrared instrument and near-infrared camera to scan the heavens, hunting for black holes. Its integrated spectrographs then dissect the light spectrum, enabling scientists to analyze the data. During their investigations, scientists stumbled upon a crucial revelation. The heated material surrounding a black hole emits faint traces of radiation across the cosmos. By scrutinizing these subtle glimmers from the universe's infancy, they detected an unexpected surge among the frequencies embedded within the light, yielding valuable insights into the cosmic mechanisms at play. The rapid emergence of black holes in our youthful cosmos remains a puzzle. Scientists persist in their quest for much younger primordial black holes, hypothesized to have formed shortly after the Big Bang, or perhaps even earlier. However, these elusive entities have yet to be unearthed. Meanwhile, two primary explanations exist for the profusion of black holes in the present-day universe. One posits that they are remnants of massive stars that formed at a significantly accelerated rate compared to contemporary stars. Alternatively, it suggested that dense gas clouds underwent sudden collapse, giving rise to these mysterious singularities in spacetime. A more plausible scenario involves a population the 3 star, a theoretical category of stars believed to have emerged roughly 200 million years post-Big Bang, predominantly consisting of hydrogen and helium. Such a star likely underwent a supernova explosion, leaving behind a black hole. Scientists are collaborating with the team responsible for developing MIRI to examine the distant galaxy's light and uncover additional clues regarding the formation of the mysterious black hole at its core. Additionally, researchers have scrutinized the early universe, witnessing the emergence of a protocluster comprising 7 interacting galaxies. This cluster, identified by the Hubble Space Telescope, stands as the most remote galaxy cluster detected by scientists. Simulations indicate that it is destined to evolve into one of the universe's oldest and largest galaxy clusters, boasting a mass nearly 100 times greater than that of our Milky Way galaxy. While the initial discovery of these galaxies was facilitated by the Hubble Space Telescope, it lacked the precision to accurately measure the distances between them. Imagine being perched high above Los Angeles, peering through a telescope. You might catch sight of Phoenix, Dallas, and Atlanta, but determining the precise distances between them would be challenging, right? Thanks to the James Webb Telescope, we now have a much clearer view. These types of clusters, scientists assert, are exceedingly rare and elusive. Although it's improbable that the JWST will stumble upon another unique system like this, the upcoming Nancy Grace Roman Space Telescope, slated for launch in early 2027, promises to enhance our capacity to identify galaxy clusters in the early universe. With its extensive survey capabilities, the Roman Space Telescope is expected to surpass the JWST by over 100 times. Returning to the discoveries made by the JWST, it was instrumental in revolutionizing exoplanet research in the 1990s, leading to groundbreaking discoveries. Presently, we have identified over 3,000 extrasolar planets, albeit only a dozen have been directly imaged. The majority of exoplanets are located so far away that we can only detect them when they pass in front of their host stars, causing a subtle dimming of light. However, the JWST has revolutionized this field. Through the use of the telescope's coronagraphs, along with its array of cameras, filters, and other equipment, scientists can now directly observe exoplanets. In 2017, a significant breakthrough was achieved by the SPHERE Consortium with the identification of a planet named HIP 65426b using the Spectroscopic High Contrast Exoplanet Research Instrument, SPHERE. HIP 65426b orbits its host star HIP 65426. In September 2022, it gained further acclaim as the first exoplanet to be directly observed by the James Webb Space Telescope. What sets this planet apart is its distinctive characteristics, coupled with the remarkable sensitivity of the James Webb Telescope, facilitating easier observation. Unlike any other planet in our solar system, HIP 65426b orbits its host star at a distance 100 times greater than that between our Sun and Earth. To put it into perspective, Pluto is merely 40 times farther from the Sun than Earth. Now, envision an exoplanet, a colossal gas giant around 12 times the size of Jupiter, situated at such a tremendous distance. Even though this distant world may appear elusive in the night sky, its luminance is still discernible, particularly when captured by Webb's infrared camera. When we gaze upon the galaxy known as M74, we are treated to a breathtaking display of its graceful spiral structure and the scattering of stars. The luminous core of the galaxy gives rise to sweeping arms that extend outward. Hubble's optical view of M74 reveals its grandeur, showcasing intricate structures resembling heat-emitting dust and gas filaments emanating from a brilliant core, all bathed in a striking electric blue hue. In the image captured by Webb, we witness the radiant glow of star-forming regions scattered throughout the spiral arms. Leveraging its infrared capabilities and combining images from both the Hubble Space Telescope and Webb, researchers have crafted a mesmerizing composite image. This composite seamlessly blends optical and infrared perspectives of the galaxy, offering a more comprehensive insight into its nature. As part of an international initiative, these three images were showcased in a documentary, enabling astronomers to juxtapose them for comparative analysis. This process facilitated the identification of regions where stars are presently forming, along with precise calculations of star cluster masses and ages. Furthermore, Webb's investigations have yielded valuable insights into the properties of minuscule dust particles traversing the vast expanses of interstellar space. Webb also captured a striking image of a distant Wolf-Rayet star, revealing a distinctive diffraction pattern. The star, designated as WR140, exhibits an unusual boxy shape surrounded by concentric rings resembling ripples. Remarkably, these discernible ring formations are not mere imaging artifacts, but genuine features of the star. These massive stars, nearing the end of their life cycles, have already expelled a considerable amount of hydrogen into space. The interaction between WR140 and its smaller companion star shapes a cloud of dust into the likeness of their neighboring star, resulting in the formation of the peculiar ring patterns. In the constellation, Virgo, the most extensively studied exoplanet beyond our solar system, orbits a distant star. This exoplanet, named WASP 39b, is situated an astounding 700 light-years away from Earth. It is a scorching gas giant similar in size to Saturn, orbiting its host star at an exceptionally close distance, approximately 8 times closer than Mercury is to the Sun. Ultimately, Webb was meticulously engineered to delve into the farthest reaches of the cosmos, and researchers have unequivocally affirmed its success in doing so. Stay tuned to Cosmic Discovery for our next episode.